15 March 1944. Eckernförde Naval Testing Range, Schleswig-Holstein, Germany. The morning fog had not yet burned off the Baltic when Korvettenkapitän Ernst Hoffmann arrived at the torpedo testing facility, his boots leaving prints in the frost that coated the concrete jetty where the experimental weapons platform sat, moored beneath camouflage netting that dripped with condensation. The V-7 torpedo, officially designated Versuchstorpedo 7 in the classified documents that Hoffmann carried in a leather case chained to his wrist, represented 18 months of development by engineers at the Torpedoversuchsanstalt in Gdynia. Men who had been tasked with solving the fundamental problem that plagued German naval operations in 1944. Allied convoy speeds had increased to the point where standard G7A and G7E torpedoes, running at 40 knots maximum, frequently missed their targets as destroyer escorts maneuvered and merchant vessels zigzagged according to patterns that grew more sophisticated each month. Hoffmann had reviewed the technical specifications 3 times during the train journey from Berlin. The V-7 utilized a revolutionary propulsion system that injected hydrogen peroxide into a combustion chamber where, decomposed at 600 degrees Celsius, the superheated steam driving a turbine that could theoretically push the weapon to 65 knots, nearly 25 knots faster than anything currently in service. The prototype rested on its cradle like a sleeping predator, 23 feet of welded steel painted in the standard dark gray of Kriegsmarine torpedoes, its nose cone polished to a mirror finish that reflected the weak sunlight now breaking through the clouds. 3 technicians in grease-stained coveralls moved around the weapon with practiced efficiency, checking fuel lines and testing the gyroscope that would keep it running straight during the 45-second burn that would theoretically carry it 4,000 meters before the hydrogen peroxide tanks emptied. Hoffmann watched as Oberleutnant zur See Klaus Weber, the facility's chief testing officer, supervised the final preparations, his breath forming small clouds in the cold air as he called out specifications to a petty officer who recorded everything in a hard-bound logbook with entries dating back to February 1943. The concept had originated not from German innovation, but from captured documents recovered from a British testing facility in Norway. Plans for an experimental weapon that the Royal Navy had apparently abandoned as too dangerous, too prone to catastrophic failure when the volatile fuel destabilized under combat conditions. German engineers, desperate for any advantage as U-boat losses mounted in the Atlantic and Mediterranean, had refined the design, replacing copper fuel lines with reinforced steel, redesigning the combustion chamber with 3 redundant pressure relief valves, installing a safety mechanism that would shut down the engine if internal temperatures exceeded design parameters. Weber approached Hoffmann and saluted, his face showing the strain of 3 weeks of preliminary tests that had resulted in 2 explosions, 1 destroyed test cradle, and minor burns to a technician who had been standing too close when a fuel line ruptured. The conversation was brief and professional. Weather conditions were acceptable, sea state was calm at less than 1 meter swells. The target vessel, Vorwärts, a decommissioned minesweeper, now serving as a remote-controlled drone, was positioned 6 kilometers offshore and would begin its run past the testing range at precisely 0900 hours. Hoffmann nodded and took his position in the observation bunker, a reinforced concrete structure built into the hillside with narrow viewing slits that looked out over the launch rails and the gray expanse of the Baltic beyond. At 0857 hours, the loudspeaker crackled with Weber's voice, confirming that all systems were nominal, fuel pressure steady at 80 bar, gyroscope calibrated, arming mechanism set for a 3-second delay after launch. Hoffmann raised his binoculars and located the Vorwärts on the horizon, a small dark shape trailing a thin line of smoke from its single funnel as it began its approach run at 15 knots, the speed of a typical merchant vessel. The countdown proceeded in Weber's steady voice, each number echoing in the confined space of the bunker where two other officers stood watching, their faces illuminated by the green glow of a radar scope that tracked the target vessel. At precisely 0900 hours, the launch command was given, and the V-7 left its cradle with a sound like tearing metal, the booster charge that propelled it down the rails producing a flash of orange flame and a cloud of white smoke that obscured the jetty for 3 seconds before the offshore wind cleared it away. Through his binoculars, Hoffman tracked the weapon's wake, a perfectly straight line of disturbed water that marked its passage as it accelerated to attack speed, the turbine's high-pitched whine audible even at this distance, as a sound like a circular saw cutting through steel. The torpedo ran true for 20 seconds, covering nearly 700 meters as Hoffman counted silently, his thumb marking time against the binocular case. Then, at 23 seconds into the run, the wake suddenly veered 15 degrees to port, the weapon's gyroscope apparently failing as it carved a wide arc away from the target course. Weber's voice on the loudspeaker remained calm but urgent, confirming gyroscope failure, noting that the weapon was now heading toward open water where it would eventually exhaust its fuel and sink in 300 meters of depth. Hoffman lowered his binoculars and turned to the junior officers, his expression revealing nothing as he stated that they would analyze the telemetry data and prepare for a second test on 17 March, weather permitting. The observation lasted another 40 seconds as they tracked the errant torpedo until its wake disappeared beyond their range of optics, somewhere out in the shipping lanes where Soviet submarines occasionally prowled, and where, in 6 hours, a Swedish neutral freighter would report a massive underwater explosion that shattered windows in its bridge and sent a column of water 30 meters into the air. An incident that would be recorded in Stockholm maritime records, but never connected to the German testing program, never investigated beyond a brief notation about possible mine detonation. Hoffman spent the remainder of the day in the facility's engineering office, reviewing frame-by-frame analysis of the launch captured by high-speed cameras, studying pressure graphs that showed a slight wobble in the gyroscope housing at 19 seconds, likely caused by harmonics from the turbine vibrating at frequencies that the original designers had not anticipated. As darkness fell over Eckernförde and the technicians secured the remaining prototype in the reinforced storage bunker, Hoffman drafted his preliminary report for Gross Admiral Dönitz, carefully noting that while the propulsion system had performed within specifications, the guidance system required substantial redesign before the weapon could be considered combat-ready, a conclusion that would delay deployment by at least 4 months and consume resources that Germany, in March 1944, could increasingly ill afford to spare. 22 June 1944. U-953, operating area, North Atlantic, 320 kilometers west of Ireland. Captain Lieutenant Heinrich Müller stood in the control room of U-953, a Type 7X U-boat that had departed Brest 17 days earlier carrying 4 modified V-7 torpedoes in specially adapted tubes that had been installed during a rushed refit that lasted only 9 days. The modified weapons, designated V-7S for Seegefecht or sea battle, incorporated a redesigned gyroscope system that used a mercury-based stabilization mechanism instead of the mechanical system that had failed during testing at Eckernförde, a change that added 14 kilograms to each weapon and reduced maximum range to 3,500 meters. The hydrophone operator, Matrosengefreiter Paul Krebs, sat hunched over his equipment in the dim red lighting of the combat station's configuration, his headphones pressed tight against his ears as he tracked the bearing and range of convoy HX-295, 23 merchant vessels arranged in 7 columns with an escort screen of 2 destroyers, 4 corvettes, and a frigate. The convoy was making 14 knots, zigzagging every 8 minutes according to a pattern that Müller's navigator, Oberleutnant zur See Friedrich Lang, had partially decoded by plotting their course changes on the chart table. Müller had selected his target with care, a Liberty ship in column 5, the SS Jonathan Edwards, a vessel of 7,400 tons carrying ammunition, vehicles, and aviation fuel destined for American 8th Air Force bases in East Anglia. At 1847 hours, Mueller gave the order to come to attack depth, and the hydroplane operators brought the boat up to 12 meters. Through the attack periscope's optics, magnifying the image 8 times, Mueller could see the Liberty ship's profile clearly. The standard design with a single funnel amidships, 5 cargo holds, a cruiser stern, the stars and stripes painted large on her hull. Long called out the firing solution. Target bearing 015 degrees, range 2,200 meters, target speed 14 knots, course 180 degrees, gyro angle set for a 90-degree port deflection. At 1851 hours and 40 seconds, Mueller gave the command to fire tube 1, and the boat shuddered slightly as compressed air drove the V-7 from its tube, the weapon beginning its run with a burst of hydrogen-peroxide ignition that left a brief trail of bubbles marking the launch point. Mueller kept his eye to the periscope, tracking the torpedo's wake as it drove toward the target in a perfectly straight line, the new gyroscope system holding true as 15 seconds passed, then 20, then 25. At 31 seconds, when the weapon should have been within 200 meters of impact, a massive explosion bloomed in the water 700 meters short of the target, a detonation so violent that it threw a column of water and foam 40 meters into the air, the shock wave striking U-953's hull with enough force to knock 2 men off their feet and shatter a pressure gauge in the engine room. The Liberty ship continued on its course, apparently undamaged, while the escorts immediately turned toward the explosion point, their screws thrashing the water as they accelerated to flank speed. Mueller ordered crash dive to 120 meters, and the boat angled down sharply as the chief engineer fought to maintain trim. For 3 hours, U-953 endured a methodical depth charge attack that dropped 67 weapons in a grid pattern, each explosion closer than the last, until at 22:14 hours, a charge detonated less than 30 meters from the boat's stern, rupturing a fuel tank and causing a small leak in the pressure hull. Mueller waited until 02:30 hours, when the escort sonar had finally lost contact, before ordering the boat to surface, the diesel engines coughing to life as they cleared the ballast tanks. The damage assessment took until dawn. 1 fuel tank ruptured, 1 ballast tank venting improperly, 3 gauges destroyed, and most critically, the remaining 3 V-7 torpedoes compromised by the depth charge attack, their sensitive guidance systems likely damaged beyond repair. Mueller stood on the bridge as first light touched the eastern horizon and composed in his mind the report he would have to file. A report that would note mechanical failure of the new weapon system, that would recommend against further deployment until the premature detonation problem could be solved. U-953 limped back to Brest at 8 knots, arriving on 29 June, and within 2 weeks both Mueller and his boat would be reassigned to operations in the Baltic, where the V-7 program would be quietly terminated. 3 February 1945, document recovery site, Kiel Naval Archive, Schleswig-Holstein, Germany. Commander James Morrison of the British Naval Intelligence Division stood in what remained of the Kriegsmarine's Central Documentation Facility, a 4-story building that had been hit by RAF Lancaster bombers during a raid in January, but whose basement archives had survived largely intact, protected by 3 meters of reinforced concrete and the systematic German bureaucracy that had filed away every technical drawing, every test report, and every operational assessment produced during 6 years of war. The air was thick with concrete dust and the smell of burned paper from the upper floors, where fire had consumed personnel records and administrative files. But here in the basement, lit by portable generators that powered harsh electric lights strung along the ceiling, Morrison and his team of 3 other officers were discovering a treasure trove of information about German naval weapons development, including a series of folders marked Geheim, for secret, and stamped with the designation V-7 Versuch Torpedo 7, Entwicklung und Einsatz, that detailed the complete history of the high-speed torpedo program from initial concept through final termination. Lieutenant Peter Hughes, a former merchant navy officer who spoke fluent German, translated the documents as Morrison photographed each page with a Leica camera loaded with fine-grained film that would be developed in London and distributed to technical intelligence sections throughout the Allied naval commands. The story that emerged from these papers was familiar to anyone who had studied German weapons development in the war's final years. Ambitious design goals compromised by material shortages, testing rushed to meet impossible deadlines, deployment ordered before problems were solved, and ultimately abandonment as resources were diverted to other projects equally desperate and equally doomed. The initial development reports from Eckernförde showed promise, with engineers at the testing facility achieving the desired 65-knot speed on multiple occasions, though gyroscope reliability remained problematic through 15 separate test launches that produced 7 successful runs, 4 guidance failures, 3 premature detonations, and 1 catastrophic explosion that destroyed the weapon on its launch rail and killed 2 technicians whose names were recorded in a casualty report dated 28 April 1944. Morrison noted that the premature detonation problem had never been fully solved, despite months of investigation that traced the failures to harmonic vibrations in the turbine housing that somehow triggered the magnetic detonator mechanism when the weapon exceeded 58 knots, a problem that should have resulted in program cancellation, but instead produced a flurry of modification orders that lowered maximum speed to 55 knots and added damping mechanisms that increased weapon weight and reduced range. The operational reports were more troubling, documenting 12 combat deployments between June and September 1944 that resulted in 0 confirmed hits, 3 premature detonations that compromised the launching submarines' positions, 2 weapons that ran circular and nearly sank their own boats, and 4 mechanical failures that left the weapons dead in the water, where they became hazards to navigation. Morrison found a particularly detailed after-action report from U-933, the boat that had attacked convoy HX-95, written in the careful prose of an experienced commander who understood that his career might depend on how he explained the weapon's failure, noting that the premature detonation occurred at 31 seconds into the run, when impact should have occurred at 34 seconds, suggesting a fault in the detonator timing mechanism that no amount of testing had revealed. The final documents in the folder consisted of a termination order dated 15 September 1944, signed by an admiral whose name Morrison did not recognize, citing unacceptable operational reliability and excessive resource requirements, and directing that all remaining V-7 weapons be returned to depot for disassembly and that components be recycled for use in conventional torpedo production. Hughes found a footnote in one report that mentioned salvage operations in the Baltic had recovered 1 V-7 weapon from shallow water near the testing range, the torpedo largely intact despite having been submerged for 4 months, allowing engineers to perform a detailed autopsy that revealed stress fractures in the turbine blades, corrosion in the hydrogen-peroxide fuel system, and a guidance mechanism that had failed because moisture had penetrated seals that were supposed to be waterproof, but had been manufactured from synthetic rubber of such poor quality that it degraded within weeks of installation. Morrison photographed everything, working systematically through the folder while British sappers secured the building above, and American Army units moved through Kiel arresting naval officers and securing what remained of the U-boat fleet that sat scuttled in the harbor, boats that would never sail again, crews that would spend the next months in internment camps being interrogated about weapons and tactics that no longer mattered. By late afternoon, Morrison had documented 317 pages of material related to the V-7 program, along with folders on acoustic torpedoes, schnorkel development, improved sonar systems, and a proposed weapon that would have used a small rocket motor to boost torpedo speed to 80 knots, a project that had never progressed beyond preliminary drawings because the requisite materials were needed for V-2 production. As the team prepared to leave, Morrison paused at one document that listed the total cost of the V-7 program: 4 million Reichsmarks for development, 6 million for modification and testing, $800,000 for production of 47 weapons, and uncalculated costs in terms of lost submarines, dead crews, and wasted opportunities to deploy proven weapons instead of experimental systems that failed when they were needed most. He thought about the engineering talent that had been devoted to this project, bright young men who might have been designing better radar or improving existing torpedoes, but who instead spent 18 months pursuing a technological solution to what was fundamentally a strategic problem. The problem that Germany was fighting enemies whose industrial capacity exceeded its own by factors that no amount of innovation could overcome. The documents went into a canvas bag that would be transported to London, analyzed by experts at the Admiralty, and eventually filed away in archives where historians would occasionally discover them and write footnotes about German torpedo development, usually ending with observations about technological sophistication wasted on a lost cause. Morrison and his team left the building as winter darkness settled over Kiel, the city silent, except for the sound of wind through bombed-out buildings and the occasional crack of small arms fire from the docks where German naval personnel were being disarmed and processed. The generators were shut down, leaving the basement archive in darkness, where folders full of careful technical German prose would wait for the next team of intelligence officers, the next round of documentation, the next stage of understanding how a war was lost, despite advantages in training, courage, and in some cases, technology that was more advanced than anything the Allies possessed, but which arrived too late, worked too poorly, or cost too much to make any difference in an outcome that had been determined by factors far beyond the reach of even the most brilliant engineering.